Welcome to the first edition of Steve's Science Sessions. Today we will be looking at our solar system. A sunrise from space, a truly spectacular view. You will notice the bright blue line around the edge of the Earth there. That is our atmosphere. Surprising how thin it is compared to the size of the Earth. We live in the Milky Way galaxy. A galaxy is a group of stars all close together. From what we can see from Earth, we are pretty sure we live in a spiral galaxy. You can see the bright centre with many stars clumped together, with tentacles of stars spiralling out from the middle. That is a spiral galaxy. We cannot see the Milky Way galaxy from this angle because we simply cannot get far enough out. But we can see many other spiral galaxies nearby and far away, so we can make a pretty good guess on what it looks like. Right at the very point of the "you are here" arrow is an intensely small, invisible speck, which is our solar system. That white circle is around about 300 light years across. It seems we need to find out what a light year is. It took thousands of years for people to realise that light even travelled at all. It's a bit like a car. It starts from one place and travels in one direction. 299,792,485 metres per second. Let's try that another way. 299,792 kilometres every second. That's almost as fast as my Lamborghini. If you could count up every second in an entire year, you would get that enormous number on the right. 9,460,528,400,000 kilometres every year. You would have to times that number by 300 to get that small white circle I showed you in the previous image. The Milky Way galaxy is about 105,700 light years across. Those numbers are even too big for my mind. Let's try think of it in a smaller way. The distance all the way around the Earth is a little over 40,000 kilometres. If light could travel in a circle, it would go around the entire Earth 7.5 times in 1 second. Almost as fast as gossip. This is a diagram or a picture of our solar system. The Sun is right in the centre and the planets all around it. The planets move around the Sun along the lines you can see. Although they're not perfect circles like this diagram, they are slightly oval shaped. Those lines are called an orbit. When a planet goes all the way around the Sun and back to where it started from is called 1 year. Something else you'll notice in this diagram, between the orbit of the red planet and the orbit of the brown stripy planet on the lower left, there is a dotty dusty area, a ring. That is the asteroid belt. All of the planets also spin. They spin around what's called an axis. If you can imagine stabbing a huge bar through the planet from top to bottom, like those orange lines you can see, that's called an axis. The planets spin on that axis, a bit like a player spinning a basketball on their finger. When a planet spins all the way around to come back to the same position it started from, that is called 1 day. This is a different diagram of our solar system. It doesn't actually look like this. The planets are never in a straight line like that, and they are way, way further apart. But this is a good way of comparing the planets to each other, to see how different they are or how they are the same. How big they are, how small they are next to each other. Our Sun, so huge only a small piece of it appears in this picture. A short distance out, almost lost in the glare from the Sun, is Mercury. The next planet out is Venus, our beautiful blue Earth, the small Mars, Jupiter, the biggest planet in our solar system, Saturn, and, okay boys, let's get this sorted out right now. It is pronounced Uranus, not Uranus. Okay? No, now, settle down. Stop the sniggering. Uranus is the next planet out. The last planet is Neptune, and if you look carefully, you may notice something missing at the end there. This is a different diagram of our solar system. Let's look at that a different way when you can fit the Sun into the picture. Our beautiful blue Earth, which seems awfully big to us who are standing on it, is barely a dot. Over to the right you can see the massive Jupiter and Saturn are tiny. The light blue planet is Uranus. The dark blue planet is Neptune. In front of those, put your glasses on guys, is Mars, Venus and Mercury. Starting to get the idea that the solar system is big. Our Sun is both ordinary and extraordinary at the same time. Astronomers call our Sun a yellow dwarf. Whoa, did he just call our enormous Sun a dwarf? Well, it is compared to some of the other stars out there. More on that in a few moments. It is extraordinary because 80% of the stars we have discovered so far are brown dwarfs and far smaller than our Sun. The diameter of the Sun is 1,392,000 kilometres. The diameter is from one edge through the centre to the other edge. The Sun does not orbit in our solar system, but it does spin on its axis. It goes all the way around every 25 days. It is made of 91% hydrogen and about 9% helium. At the core, right in the centre, the temperature is about 15 million degrees Celsius. That's enough to sustain thermonuclear fusion. That one gets a bit tricky. We won't get into it. But imagine it as a massive hydrogen bomb that's 1.4 million kilometres across. The surface of the Sun is a balmy 5,500 degrees Celsius. Let's not forget that our Sun is actually a star. It's just a star that happens to be very close to us. And nearest stellar neighbour is Proxima Centauri, and that is over 2 light years away. Our solar system is moving at an average velocity of 720,000 kilometres per hour as it orbits the centre of the Milky Way galaxy. It would take about 230 million years to make one complete orbit around the Milky Way. Stars are classified by colour and size. You can get red, white, yellow and blue. You can also get dwarf, giant, supergiant and hypergiant. Examples are a red dwarf or a white dwarf, yellow supergiant, blue hypergiant, and the biggest star we have discovered in our universe so far, VY Canis Majoris, is a red hypergiant. Our Sun, on the bottom left of this picture, looking a little bit frightened, is compared to the other sizes of stars that we have found. Right up to that blue hypergiant that only a quarter of will fit in this picture. If VY Canis Majoris was put in the same place as our Sun, the outside edge would reach out to Jupiter. Yes, our rocky terrestrial planets would be atomised, and poor old Jupiter would probably evaporate into mist. The first object out from the Sun is Mercury, at a distance of 58 million kilometres. Mercury's surface can reach 430 degrees. Because the planet's atmosphere is so thin, it can't keep that heat, so nighttime temperatures drop to minus 180 degrees. Its orbit around the Sun takes 88 Earth days. Travelling through space at nearly 50 kilometres per second, faster than any other planet. One Mercury day is equal to 176 Earth days. It spins very slowly on its axis. It has no moons, but closely resembles Earth's moon. Many large impact basins and craters, including Caloris, 1,550 kilometres in diameter. That's almost all the way from Melbourne to Brisbane. Can you imagine a crater that big? The next planet out is Venus, at 108 million kilometres from the Sun. Venus and Earth were often called twins or sister planets because they're very similar in size, mass, density, what they're made of, and their gravity. But that is where the similarities end. Venus is covered in many volcanoes with lava flows thousands of kilometres long. It has no moons, but it does have a runaway greenhouse effect. You've heard on Earth talk about global warming and the gases in our atmosphere stopping the heat from escaping. Venus has taken this to the extreme. gets to 465 degrees on Venus, that's hot enough to melt lead. Even hotter than Mercury, which is 50 million kilometres closer to the Sun. It has an atmosphere very thick with clouds of carbon dioxide and sulfuric acid. Yes, it rains sulfuric acid on Venus. If you're going out for a walk, take a very sturdy umbrella. The surface pressure, which is the weight of all that air pulled down by the gravity, is 90 times that of Earth. It would be like going 1.5 kilometres deep underwater. Winds blow up to 355 kilometres an hour. Over 40 small spacecraft have been sent to Venus. About 11 have survived the harsh conditions to land on the surface. The best lasted less than 2 hours. NASA's Pioneer survived 45 minutes before failing. It has a mountain 8.8 kilometres high. That's taller than Mount Everest. It takes 243 Earth days to rotate on its axis and 225 days to orbit the Sun. On Venus, the Sun would rise in the west and set in the east. Scientists don't exactly know why this is so. It's very confusing. Our gorgeous blue Earth. No other planet is anything like it. At 150 million kilometres from the Sun, our orbit, or year, takes 365 days. 1 day is equal to 24 hours and 15 minutes. It is the only planet with liquid water. Our atmosphere is 78% nitrogen, 21% oxygen. Our thick atmosphere and our strong magnetic field are very helpful to us because they deflect most of the nasty radiation coming from the nuclear reaction in our Sun. Something like 300,000 objects enter our atmosphere every year. But most of them are so small they burn in the atmosphere. A bit like the spacecraft re-entering. Occasionally they hit the Earth when they are called meteorites. Earth is called a Goldilocks planet because it lives in the Goldilocks zone, just far enough away from the Sun to make life possible here. They call it Goldilocks because it's not too hot, not too cold, it is just right. Our moon. Of the 190 moons in the solar system, this one is the 5th largest. It is 385,000 kilometres from Earth. It is what's called tidally locked. That means it spins on its axis so slowly that the same face is pointing towards Earth all the time. It has a very thin atmosphere. There have been 105 unmanned spacecraft sent to the moon. It has mountains and valleys and many craters from impacts of meteors and meteorites. It is largely covered in a dust called regolith. Men have brought back 382 kilograms of rock and soil back to Earth. The red planet, Mars. It is 228 million kilometres from the Sun. It has a 687-day orbit and a 24 hours and 37-minute day. It has a thin atmosphere of carbon dioxide, argon and nitrogen. The average temperature is minus 60 degrees. It has many ancient volcanoes that are no longer active. Mars has 2 small moons. In 2008, NASA's Phoenix Mars lander was the first mission to touch water ice on the Martian Arctic. Phoenix also observed snow. You can see the polar ice cap in the picture. At around 400 million kilometres from the Sun, you will find the asteroid field. Although I must say, it looks nothing like this. If you are standing on an asteroid, the next one would be so far away you probably couldn't even see it. But asteroid fields, computer generated like this one, are much more exciting to fly a Millennium Falcon through. The asteroid belt is about 280 million kilometres wide and 80 million kilometres thick. Asteroids range in size from Vesta, the largest, at about 530 kilometres in diameter, to bodies that are less than 10 metres across. If you were to take all of the asteroids and squash them into a ball, it would be smaller than Earth's moon. The belt is estimated to contain between 1.1 and 1.9 million asteroids larger than 1 kilometre, and millions of smaller ones. Over 200 asteroids are known to be larger than 100 kilometres. They revolve around the Sun in elliptical or oval-shaped orbits, just like the planets. The asteroids also rotate, but a lot of them don't rotate on an axis. They rotate quite erratically, even tumbling as they go. More than 150 asteroids are known to have a small moon. Some have 2 moons. There are also binary or double asteroids, in which 2 of them are roughly equal in size, orbit around each other, as well as some triple asteroid systems. We now get to the giant planets. Jupiter is a gas giant. It is 778 million kilometres from the Sun. One day on Jupiter takes only about 10 hours. It spins very fast. Its orbit is about 12 years. It is the largest planet in the solar system, more than twice all the other planets added together. If Earth was the size of a grape, Jupiter would be the size of a basketball. As a gas giant, it has no solid surface, so you cannot land on Jupiter. The atmosphere is mostly hydrogen and helium. The stripes and swirls we see are windy clouds of ammonia and water. Ammonia is usually used in cleaning products. In 1979, the Voyager spacecraft discovered a faint ring system. All the 4 giants have a ring system. It has 79 confirmed moons. Jupiter also has 3 rings. It is 11 times wider than Earth. Sunlight takes 43 minutes to travel from the Sun to Jupiter. Winds, some reaching 539 kilometres per hour at the equator. The Great Red Spot, a swirling oval of clouds twice as wide as Earth, has been observed on the giant planet for more than 300 years. Next out is Saturn at 1.4 billion kilometres from the Sun. It takes 29 years to orbit, and its day is 10.7 hours. This fast spin causes Saturn to bulge in its middle. It is a massive ball of mostly hydrogen and helium. Saturn is the only planet in our solar system that is less dense than water. This gas giant would float in water. Winds in the upper atmosphere reach 500 metres per second. In contrast, the strongest hurricane-force winds on Earth are 110 metres per second. It has 53 moons and 29 suspected moons waiting to be confirmed. One of them, Titan, is bigger than Mercury. Saturn's rings are believed to be pieces of comets, asteroids, or even shattered moons that broke up before they reached the planet, torn apart by Saturn's powerful gravity. They are made up of billions of small chunks of ice and rock. The ring particles mostly range from tiny, dust-sized icy grains to chunks as big as a house, though a few particles are as large as mountains. Uranus is 2.9 billion kilometres from the Sun. That's more than twice as far as Saturn. Its day is 17 hours long, and its year takes 84 years. It is the first planet to be discovered using a telescope in 1781. Uranus and Neptune are both ice giants. 80% of the planet's mass is made up of a dense or tightly packed fluid of icy materials, water, methane and ammonia, above a small rocky core. Uranus has 13 faint rings and 27 moons. It spins east to west. But if Venus was very naughty, Uranus is extremely naughty. It rotates at nearly 90-degree angle from the plane of its orbit, which means it rolls around its orbit. It takes sunlight 2 hours and 40 minutes to travel from the Sun to Uranus. For nearly a quarter of each Uranian year, the other half of the planet is in a 21-year-long dark winter. With a minimum temperature of minus 224 degrees, it makes it even colder than Neptune at some places. Wind speeds can reach up to 900 kilometres an hour. On Uranus, winds are retrograde. That means going backwards, at the equator, blowing in the reverse direction of the planet's rotation. But closer to the poles, winds shift to a prograde direction, flowing with Uranus's rotation. Neptune, at 4.5 billion kilometres from the Sun, that's 30 times further from the Sun than Earth. Its day is equal to 16 hours, and its orbit is 165 years. Light travel time, 4 hours. It is an ice giant, the same as Uranus, which also means it doesn't have a solid surface. It does have 14 moons. One of them, Triton, has a retrograde orbit, which means it orbits the planet in the opposite direction of the planet's spin. Voyager 2 saw geysers squirting icy material 8 kilometres high. That's taller than Mount Everest. It has at least 5 rings and 4 partial rings. It was mathematically predicted before it was seen in 1846. That means some guy, looking at the orbits of other planets, realised that there was another planet out there before it could be found. Winds of frozen methane at more than 2,000 kilometres an hour. That's as fast as an FA-18 fighter jet. Sunlight on Earth is 900 times brighter than sunlight on Neptune. Did you guess what was missing from those diagrams of the solar system I showed earlier? Poor old Pluto, at a distance of 5.8 billion kilometres from the Sun. With a tear in its eye, it takes 248 years to orbit the Sun. Spinning slowly, its day takes 6 days and 10 hours. Pluto is about 2/3 the diameter of Earth's moon, and probably has a rocky core surrounded by water ice. More exotic ices like methane and nitrogen frost coat its surface. It has an atmosphere of nitrogen, methane and carbon monoxide, meaning Pluto has blue skies. Pluto has 5 moons. One of them is almost half its size. The temperature there is about minus 235 degrees. Just as you thought kids were insignificant, the name of Pluto was suggested by an 11-year-old girl, Venetia Burnley, in 1930. Snow on the planet Pluto is red. Yes, you heard correctly, I still call it a planet. Poor old Pluto has been demoted to a dwarf planet. Why was it changed? Well, many years ago, people predicted another planet beyond Neptune. When they discovered Pluto, they thought this was it. The further Pluto has stayed, the more we realised it wasn't the planet we were looking for. It became smaller and smaller and smaller. It's not even big enough to form a complete round. You'll see it's kind of flattened. The other thing is Pluto's orbit. You can see the rest of the planet's orbit on a flat plane. Pluto dips below the other planets on the left and way higher than the other planets on the right. That was the other reason it was demoted. Now called a dwarf planet, is also called a Kuiper Belt object. The Kuiper Belt is similar to the asteroid belt, but made of millions of icy bodies in a donut shape, which includes Pluto. It starts at about 6 billion kilometres from the Sun and extends out to about 7.5 billion kilometres from the Sun. It was not discovered until 1992, about the time the 2 Voyager spacecraft passed nearby. Over 2,000 objects have been catalogued. Hundreds and thousands of objects are larger than 100 kilometres. We don't really know much about the Kuiper Belt because it is so far out. Here are some of the Kuiper Belt objects that have been discovered. The names of the objects are underneath. The names of their moons are above. You can see the size of Pluto's moon, Charon, compared to Pluto. You'll also notice that some are even bigger than Pluto. One other thing worth noting as you look along these names is that astronomers are often not very creative. The Kuiper Belt is the last known natural object of our solar system, but there are a few things further out but are not natural. There have been a number of spacecraft sent out that have gone past the Kuiper Belt, and one who is still in it. Pioneer 10 was launched on the 2nd of March 1972 at a speed of about 52,000 kilometres an hour. After its launch, it passed the Moon in just 11 hours and crossed the Mars orbit, 50 million miles away, in just 12 weeks. Accelerated by the massive gravity of Jupiter to a speed of 132,000 kilometres an hour, it passed Jupiter within 130,000 kilometres on December the 3rd, 1973. There has been no contact with Pioneer 10 since 2003. Pioneer 11 was launched on the 5th of April 1973. It passed through the Asteroid Belt on the 19th of April 1974. It passed Jupiter within 43,000 kilometres above the cloud tops. The close approach also allowed the spacecraft to be accelerated by Jupiter to a velocity of 55 times that of the muzzle velocity of a high-speed rifle bullet, 175,000 kilometres an hour, on its way to Saturn. Saturn, on the 1st of September 1979, Pioneer flew within 20,000 kilometres. It took the first close-up pictures. Instruments located 2 previously undiscovered small moons and an additional ring. November 1995 was the last time we had communication with it. The twin spacecraft Voyager 1 and Voyager 2 were launched by NASA in separate months during 1977 from Cape Canaveral in Florida. As originally designed, the Voyagers were to conduct close-up studies of Jupiter, Saturn, Saturn's rings, and the larger moons of the 2 planets. The Voyager mission was designed to take advantage of a rare geometric arrangement of Jupiter, Saturn, Uranus and Neptune, which only occurs about every 175 years. While the 4-planet mission was known to be possible, it was also deemed too expensive to build a spacecraft that could go that distance, carry the instruments needed, and last long enough to accomplish such a long mission. So the Voyagers were funded to conduct intensive flyby studies of Jupiter and Saturn only. More than 10,000 trajectories were studied before choosing the 2 that would allow close flybys of Jupiter and its large moon Io, Saturn and its large moon Titan. The chosen flight path for Voyager 2 also kept the option to continue on to Uranus and Neptune. Voyager 2 encountered Uranus on January the 24th, 1986, and Neptune on August the 25th, 1989. Although not designed to go past Neptune, both spacecraft are still operating. That's a real nod to NASA and how well they built these craft. Voyager 1 has crossed into the heliosheath and is leaving the solar system. Both spacecraft will continue to study ultraviolet sources among the stars and energy fields, and particle instruments aboard the Voyagers will continue to explore the boundaries between the Sun's influence and interstellar space. The Voyagers are expected to return valuable data for at least another decade. Communications will be maintained until Voyager's power sources can no longer supply enough electrical energy to run critical systems.